Well, I'm not going to work this all out for you, but the point is, again, we've treated our system as a matrix system. For this matrix, we've come up with a solution. This system is equivalent to this system of equations in a very straightforward way. This system is just like this system, okay, where phi is a y1, y2. We get this for our phi matrix, and we express that as two column vectors, y1 vector, y2 vector, write out our fundamental set, a little bit of notation here. Now the question is the y1 vector a solution to this equation? The y1 vector has a y1 function and a y2 function, so if we let y1 be this and y2 be this, that is, we let y1 be our y1, 1 vector, and y2 be our y2, 1 vector, component of function. Do these, if I set this equal to y1, this equal to y2, plug it in here, does it work? Okay? Well, let's see. Y1 vector gives us y1 function equal this. Now we don't use the y11 and y21 here because we're just confining our attention to this vector to see if it works. So we're going to call this function y1, we're going to call this function y2. We don't have to distinguish it from these two because we're not considering these two. Okay, so we have y1, y2, this and this. Plug them in here, does it work? Okay, well, I asked people to verify that. After a few minutes, somebody said, well, is that y1 prime a matrix multiplication or something? And, you know, and that's the kind of question you expect because the notation gets so confusing. Okay, that's why we want to write out the notation very, very carefully. And of course my response was, no, y1 prime is the derivative of y1. And, you know, the person immediately broke out laughing because it was so obvious what that meant. And there's no shame in asking that question or seeing that because of the confusion and all the notation. So that helps get straight on what the notation means. Well, it's very easy to verify this. You know, y1 prime, you just take that derivative, it's 8e to the 2t minus 3e to the t. Okay, I don't have to tell you why that is. And that should equal 5y1 minus 4y2. Well, 5y1 is 5 times this. Right there we have it, 5y1. y2 is this, so right here is minus 4y2. Multiply it out. We get 5 times 4e to the 2t, and we get negative 4 times 3e to the 2t. That's 20 minus 12e to the 2t, which is 8e to the 2t, and that matches the e to the 2t coefficient here. Okay? And then we have 5 times negative 3e to the t, and negative 4 times negative 3e to the t. That's negative 15 and plus 12e to the t, which is negative 3e to the t, and bingo, it matches. Now I say here, so far so good, and I'm pretty confident that if you then do the same thing for these, let this be y1 and let this be y2, you're going to get a solution. Okay, well, now where does that leave us? If we have a system and we have an initial condition or something of that nature.